Hi everybody, Chris AMS. Welcome to another video. Today's just going to be a quick one. We've got a Honda CRV in with us. It's a diesel. The customer's complaint is that the battery light's on and that the charge voltage is erratic. Now the customer reports that they've replaced the battery on the vehicle and they've also replaced the alternator on the vehicle, attempting to rectify the issue, and the fault remains. So hence it's here with us. So let's get into it and see if we can figure out what's wrong with this one. So the first couple of checks that we've carried out, standard checks, we've checked the health of the battery. The battery is okay, although it says it's a little low on charge and could do with a recharge. And we've checked the charging system, and the charging system failed a crank test, and it also failed on charging at idle. So it's shown that there's an issue there. So our next step is we're going to give it a quick plug in, and we're going to give it the vehicle code scan, because it's also bringing up a engine management warning as well in conjunction with the battery light, and we'll see what the code scan reveals. So we've plugged we're using the Snap-on Zeus this morning, and we've carried out a code scan of the vehicle, and we've got 3 fault codes to do with vehicle charging there, and we've also got a glow plug issue there that we may or may not look at later on for the customer. So the engine management system is seeing a charging issue. Now what we do next is, if we go to our wiring diagram for this, we're using E3 Technical. You can see there that we have a LIN bus controlled alternator. So we got power in straight off the battery, and then this little wire here coming off B1 goes off to our engine computer, which controls the charge rate of the alternator. Let's say it's a smart charge system, and then that lists a DC to DC converter. I assume that's probably only relevant to a vehicle that is a hybrid, which this isn't. So we can forget that. We're just looking at this bit here. Now, in order to check a LIN bus controlled alternator, you do require an oscilloscope. And we are going to break out the oscilloscope, and we're going to have a look at what this alternator is doing and what the circuitry is doing. So here under the bonnet, we've got the Zeus scope out, the 4-channel scope, and down there is our alternator. So our yellow channel was attached to battery positive to the alternator, and our green channel is going into the single wire on the back of the alternator. So as I said before, this alternator is relatively new, and as is the battery. The battery's got Halfords written all over it, so the likelihood is that the battery is going to be of a similar, the alternator is going to be of a similar quality. So first thing we're going to do is we're going to check our LIN bus signal with just ignition on and see what we got. We're in the vehicle, let's start her up. As you can see in the corner there, we've got our battery light on. Obviously the bonnet's open, let's get rid of that. And we've got a battery warning there. And PGMFI is basically the engine warning, I think, as well. So our battery light's on. Let's have a look at what the scope shows. So as you can see, on the green channel we have our LIN bus signal, and on the yellow channel we have our battery voltage. Now our battery voltage, you can't see that very well from here, is about 11.5 volts, 11.6, something like that. So it's not charging correctly. Now if I give it a rev, and we can actually get the battery light, well, the battery light stays on, but we can get this thing to charge, and it's basically because it's a failed state. It's in a failed state, it charges, you know, the alternator charges because you can see itself spinning quickly. So let's do that now. So hopefully from what you can see there, now we're up to 14 volts on the charger. The battery, the warning light's still on, the engine light is still on. And based on everything, all the available evidence, it's the alternator. So there you go. Just shows quick testing and methodical testing. We've proved that we've got a new faulty alternator. Now the alternator that's been fitted to the vehicle is aftermarket. I personally have never had any luck fitting aftermarket limb bus alternators. I always go genuine. I had one on a Ford once that within 2 minutes of the engine running was at 150 degrees. Now that was a Bosch alternator. It wasn't any cheap old crap off of eBay. It was a good quality alternator, although it wasn't one that worked with that van. I also had a BMW that wouldn't charge correctly with a Bosch alternator on, or I tried 2 alternators on it, and only a genuine alternator would rectify that issue as well. So our recommendation to the customer is to get a genuine alternator fitted, and that should rectify his issue. Right, so we've got a replacement alternator installed. We've gone genuine, we've got one from Honda. This is the old alternator off the vehicle. Now, like I said, this has been replaced at some point before. If you look at it, it doesn't look overly old. Although, if you look around it, there is absolutely no markings on it whatsoever to indicate brand or anything like that. So this is going to be what I can only assume is the cheapest of cheap alternators. And it's all been kind of busted up and knackered. Now, remember we was talking about the LIN bus control on it. It's a single wire connection there. That's the control side for the alternator. So the new one is installed down there, and we've tested it, and the battery light goes straight out, but we'll show you the results off of it. Now, like I said before, I've never had an aftermarket alternator work well on a LIN bus control system. I've always fitted genuine, because I've had too many times where I've replaced it, it hasn't worked, and then I ended up having to swap it out for a proper one. So you buy cheap, buy twice. This is probably like 100 quid, 150 quid I've seen these going for in the aftermarket. The new one, more like the £800–900 mark. So you can understand where the quality is and where it's, there's a reason that the proper ones are that money, and the reason that this one is so cheap is it don't bloody work. In order to test the battery, we used our Sealy battery tester BT3000. I can take you through a test on this. I'll show you the test of the good one kind of thing, and yeah, you see how that works. So sat in the vehicle, let's go for a quick battery test and show you, or charging system test in this instance. So on the screen is the initial test that we carried out on the vehicle and shown that the original alternator was faulty and not charging correctly. So the Bluetooth Sealy tester requires a Bluetooth Sealy app in order to work. So I'll turn it around and you can follow through the test process. So we're going to go into test once it's connected. We're going to click on charging system, which is that one, and then we're going to hit start test. Now it's asking me to turn the lights off, the heater off, the radio off and all that, and start the vehicle. So I'm going to do that now, and it's going to see that, and it's come up 9.72 volts, cranking volts detected, and it's passed it. Okay, so the next test it's going to do, we're going to hit next. It's going to make sure all the ancillaries are off, so your lights, your heater and everything are all switched off, and we're going to hit next, and it's going to do an idle cranking test. Now this failed on our initial with the other alternator on. Now it's seeing 14.3 volts. It's happy that that's working correctly. We click on next. Now it wants to do a test of the charging system under load, so we're going to turn our lights on, we're going to turn our heater on, and it's asking us to rev the engine so it's above between 1,000 and 2,000 RPM. So we're going to do that, get it to about 1,500 RPM, and then we're going to hit next. Now that is going to do a countdown. Ooh, I might have just knackered this test, sorry, because I can't keep my foot still. And let's see what that does. So what that's looking at is engine ripple. Okay, let's turn this heater off a sec. We'll talk about that in a sec. So it's engine ripple. And then the last test is alternator loaded at 14.3 volts. So that's all tickety-boo. It's happy with all the tests. And if we click on that, turn off vehicle, you can see all that, all pass, and pass. So we've proved that our charging system is now okay. So there you have it, another vehicle fixed and diagnosed correctly. Again, that was a very expensive alternator, so it's very important that we got the diagnosis correct. I don't want to be sat on £1,000 alternator because it didn't fix the problem. Really hope you enjoyed the video. Don't forget to like and subscribe. Check out some of our other videos. There'll be links to it in the screen here somewhere, and we'll see you in the next one. So take care.